Welcome to ICRA Juvenile e-Learning Platform. CCNA Exam V1.0, CCNA 200-301, exam description, is a 120-minute exam associated with the CCNA certification. This exam tests a candidate's knowledge and skills related to network fundamentals, network access, IP connectivity, IP services, security fundamentals, and automation and programmability. The course, Implementing and Administering Cisco Solutions, CCNA, helps candidates prepare for this exam. The following topics are general guidelines for the content likely to be included on the exam. However, other related topics may. Network fundamentals explain the role and function of network components, routers guide and direct network data, using packets that contain various kinds of data, such as files, communications, and simple transmissions like web interactions. The data packets have several layers, or sections, one of which carries identifying information such as sender, data type, size, and most importantly, the destination IP, Internet Protocol, address. The router reads this layer, prioritizes the data, and chooses the best route to use for each transmission. Types of routers: wired and wireless routers. These routers are mostly used in homes and small offices. Wired routers share data over cables and create wired local area networks, LANs, while wireless routers use antennas to share data and create wireless local area networks, WLANs. Edge routers. This is a wired or wireless router that distributes data packets between one or more networks but not within a network. As their name indicates, edge routers are placed at the edge or boundary of networks and typically connect to Internet Service Providers, ISPs, or other organizations' networks. Their job is to keep your network communicating smoothly with other networks. Core routers. These wired or wireless routers distribute data packets within networks but not between multiple networks. They're designed to become the backbone of your network and do the heavy lifting of data transfer, which is why they're usually high performance. Virtual routers. Unlike physical router B, 2-layer and 3-layer switches, traditional switching operates at layer 2 of the OC model, where packets are sent to a specific switch port based on destination MAC addresses. Routing operates at layer 3, where packets are sent to a specific next hop IP address based on destination IP address. Devices in the same layer 2 segment do not need routing to reach local peers. What is needed, however, is the destination MAC address, which can be resolved through the Address Resolution Protocol, ARP, as illustrated below. A layer 3 switch is basically a switch that can perform routing functions in addition to switching. A client computer requires a default gateway for layer 3 connectivity to remote subnets. When the computer sends traffic to another subnet, the destination MAC address in the packet will be that of the default gateway, which will then accept the packet at layer 2 and proceed to route the traffic to the appropriate destination based on its routing table. C. Next generation firewalls and IPs of traditional firewall provides stateful inspection of network traffic. It allows or blocks traffic based on state, port, and protocol, and filters traffic based on administrator-defined rules. A next generation firewall, NGFW, does this, and so much more. In addition to access-controlled, NGFWs can block modern threats such as advanced malware and application layer attacks. According to Gartner's definition, a next-generation firewall must include standard firewall capabilities like stateful inspection, integrated intrusion prevention, application awareness and control to see and block risky apps, threat intelligence sources, upgrade paths to include future information feeds, techniques to address evolving security threats. D. Access points. A wireless access point, WAP, is a networking device that allows wireless-capable devices to connect to a wired network. It is simpler and easier to install WAPs to connect all the computers or devices in your network than to use wires. And E. Controllers. Cisco DNA Center and WLC. Cisco DNA Center is the network management and command center for Cisco DNA. With this platform, it can respond to changes and challenges faster and more intelligently. The Cisco DNA Center is a complete network management platform with integrated tools for network management, automation, virtualization, analytics and assurance, security, and Internet of Things connectivity. The DNA Center dashboard provides an intuitive and simple overview of network health and clear drill-down menus for quickly identifying and remediating issues. 1. Some important points on Cisco DNA Center. 2. Cisco DNA Center is all about automation. 3. Cisco DNA Center is based on something called intent-based networking. 4. It is open and inclusive. 5. The Cisco DNA Center dashboard provides 360-degree visibility. 6. We can vastly reduce deployment and provisioning times with Cisco DNA Center. 7. Cisco DNA Center takes the guesswork out of network performance capabilities. 8. Cisco DNA Center detects and mitigates threats in real time. 9. Lower costs. WLC, wireless LAN controller. Wireless networks have become a necessity today. Many corporate environments require deployment of wireless networks on a large scale. Cisco has come up with the concept of the Cisco Unified Wireless Network (CUWN) solution, which helps make it easier to manage such large-scale deployments. WLC is a device that assumes a central role in the CUWN. Traditional roles of access points, such as association or authentication of wireless clients, are done by the WLC. Access points, called lightweight access points, LAPs, in the unified environment, register themselves with the WLC and tunnel all the management and data packets to the WLCs, which then switch the packets between wireless clients and the wired portion of the network. All the configurations are done on the WLC. LAPs download the entire configuration from WLCs and act as a wireless interface to the clients. A wireless LAN, or WLAN, controller is used in combination with the Lightweight Access Point Protocol, LWAPP, to manage lightweight access points in large quantities by the network administrator or network operations center. The wireless LAN controller is part of the data plane within the Cisco wireless model. Endpoints. An endpoint is a remote computing device that communicates back and forth with a network to which it is connected. Examples of endpoints include desktops, laptops, smartphones, tablets, servers, workstations. Internet of Things, IoT, devices. Servers. A server is a computer that provides data to other computers. It may serve data to systems on a local area network, LAN, or a wide area network, WAN, over the internet. Many types of servers exist, including web servers, mail servers, and file servers. Each type runs software specific to the purpose of the server. 1.2 Describe characteristics of network topology architectures. A. Two-tier. It is like client-server architecture, where communication takes place between client and server. B. Three-tier. By looking at the below diagram, you can easily identify that three-tier architecture has three different layers. 1. Presentation layer. 2. Business logic layer. 3. Database layer. C. Spine leaf. A spine leaf architecture is data center network topology that consists of two switching layers, a spine and leaf. The leaf layer consists of access switches that aggregate traffic from servers and connect directly into the spine or network core. Spine switches interconnect all leaf switches in a full mesh topology. D. WAN. Wide area networks, or WANs, provide network communication services in the workplace, connecting locations that can be spread out anywhere in the world. A topology is a description of a layout or arrangement. Applying the concept of topologies to WANs involves two different but interrelated perspectives. One perspective to consider is the physical topology, which describes the physical arrangement of network devices that allow for data to move from a source to a destination network. Another perspective is the logical topology, which describes how data moves over the WAN. E. Small office home office, SOHO, as seen from the diagram above, a small office home office, SOHO, network consists of wired, desktop computers, and wireless, laptops, and stations, a wireless access point, AP, a layer 2, 2 lira, switch, one or more servers, a firewall and a layer 3, 3 lira, router. F. On-premises and cloud. On-premises. In an on-premises environment, resources are deployed in-house and within an enterprise's infrastructure. An enterprise is responsible for maintaining the solution and all its related processes. Cloud. While there are different forms of cloud computing, such as public cloud, private cloud, and a hybrid cloud, in a public cloud computing environment, resources are hosted on the premises of the service provider, but enterprises are able to access those resources and use as much as they want at any given time. 1.3 Compare physical interface and cabling types. A. Single-mode fiber, multi-mode fiber, copper. Single-mode fiber, a fiber featuring a small light-carrying core of about 9 micrometers, μm, in diameter. For reference, a human hair is closer to 100 μm. The core is surrounded by a cladding that brings the overall diameter of the optical fiber to 125 μm. Multimode fiber, a fiber with a core of 50 μm or above. A larger core means multiple modes, or rays of light, can travel down the core simultaneously. Just like single mode, the core is surrounded by a cladding that brings the overall diameter of the optical fiber to 125 μm. Shielded twisted PAIR (STP). STP cables reduce electrical noise and electromagnetic radiation. In other words, they help to keep the signal steady and reduce interference with other devices. Given below is a diagram showing a typical shielded twisted pair cable. Unshielded twisted PAIR (UTP). UTP cables do not have shielding to reduce interference. They are designed to cancel electromagnetic interference with the way the pairs are twisted inside the cable. Unshielded twisted cables are most widely used for office LANs, though recently wireless LANs are more widely used. Unshielded cables are lightweight, thin and flexible. They are also versatile and inexpensive. A typical UTP cable cross-section B, connections, Ethernet shared media and point-to-point computers connected by communication channels that each connect exactly two computers with access to full channel bandwidth. Forms a mesh or point-to-point network. Allows flexibility in communication hardware, packet formats, etc. Provides security and privacy because communication channel is not shared. Number of channels grows as square of number of computers shared or broadcast channel. All computers connected to a shared broadcast-based communication channel and share the channel bandwidth. Security issues as a result of broadcasting to all computers. Cost-effective due to reduced number of channels and interface hardware components. C. Concepts of PoE. Power over Ethernet. PoE is a technique for delivering DC power to devices over copper Ethernet cabling, eliminating the need for separate power supplies and outlets. While PoE doesn't add Ethernet data capabilities, it does offer expanded options for how and where Ethernet end devices can be placed. 1.4 Identify interface and cable issues, collisions, errors, mismatch duplex, and/or speed. What is a collision error? Collision error alerts are generated when the Ethernet settings on your Cisco email security appliance, ESA, are incorrectly configured. Typically these errors occur when the media settings of the ESA and the switch port to which it is attached do not match. A half-duplex transmission could be considered a one-way street between sender and receiver. Full duplex, on the other hand, enables two-way traffic at the same time. A communications channel can be used to communicate one way at a time or in both directions at once. Switch port duplex mismatch problems occur when the switch port and attached computer are not configured to use the same duplex setting, or for both ends, to auto-negotiate the setting. In a virtual environment, technically if there is a speed duplex mismatch on the switch port it will result in constant packet loss. TCP Transmission Control Protocol. TCP is a connection-oriented protocol. TCP allows half-closed connections. As a message makes its way across the internet from one computer to another. This is connection-based. TCP is suited for applications that require high reliability and transmission time is relatively less critical. HTTP, HTTPs, FTP, SMTP, Telnet SSH. Using TCP port number TCP rearranges data packets in the order specified. The speed for TCP is slower than UDP. There is absolute guarantee that the data transferred remains intact and arrives in the same order in which it was sent. TCP header size is 20 bytes. Source port, destination port, checksum data is read as a byte stream. No distinguishing indications are transmitted to signal message, segment, boundaries. TCP is heavyweight. TCP requires 3 packets to set up a socket connection before any user data can be sent. TCP handles reliability and congestion control. TCP does flow control. TCP requires 3 packets to set up a socket connection before any user data can be sent. TCP handles reliability and congestion control. TCP does error checking and error recovery. Erroneous packets are retransmitted from the source to the destination. 1. Sequence number 2. ACK number 3. Data offset 4. Reserved 5. Control bit 6. Windows 7. Urgent pointer 8. Options 9. Padding 10. Checksum 11. Source port 12. Destination Port Acknowledgement Segments UDP User Datagram Protocol or Universal Datagram Protocol. UDP is a connectionless protocol. Not applicable for UDP protocol. UDP is also a protocol used in message transport or transfer. This is not connection-based, which means that one program can send a load of packets to another, and that would be the end of the relationship. UDP is suitable for applications that need fast, efficient transmission, such as games. UDP's stateless nature is also useful for servers that answer small queries from huge numbers of clients. DNS, DHCP, TFTP, SNMP, RIP, VoIP, IPTV using UDP port numbers. UDP has no inherent order as all packets are independent of each other. If ordering is required, it has to be managed by the application layer. UDP is faster because error recovery is not attempted. It is a best effort protocol. There is no guarantee that the messages or packets sent would reach at all. UDP header size is 8 bytes. Source port, destination port, checked. Some packets are sent individually and are checked for integrity only if they arrive. Packets have definite boundaries which are honored upon receipt, meaning a read operation at the receiver socket will yield an entire message as it was originally sent. UDP is lightweight. There is no ordering of messages, no tracking connections, etc. It is a small transport layer designed on top of IP. UDP does not have an option for flow control. UDP does error checking, but simply discards erroneous packets. Error recovery is not attempted. 1. Length 2. Source port 3. Destination port 4. Checksum no acknowledgement. 1.6 Configure and verify IPv4 addressing and subnetting IP address. Each device that connects to the internet needs a unique identifying number with which to communicate, called an IP addresses. IP stands for Internet Protocol. There are two versions of IP that currently coexist in the global internet: IP version 4, IPv4, and IP version 6, IPv6. IP addresses are made up of binary values and drive the routing of all data over the internet. IPv4 addresses are 32 bits long, and IPv6 address is 128 bits long. Subnetting, as a basic definition, subnetting is dividing the network into smaller network groups and, by doing this, using the IP address block more efficient. CIDR versus VLSM. CIDR, classless inter-domain routing, is the term that is used for using IP addresses independent from their traditional AP classes. In other words, CIDR is using IP addresses without classes. VLSM, variable length subnet mask, is the term that is used for using different subnet mask for different subnetworks. In other words, it is the mechanism that allows different subnet masks and provide division of a network into subnetworks. It is like subnet of subnets. Special subnets in subnetting. Some subnet masks are used specifically sometimes. These are 24, 30, 31 and 32. 24 is the subnet mask that is usually used in the local networks by default. 32 is the subnet mask used generally on loopback and system interfaces. 31 is the subnet mask used on point-to-point links. 30 is also widely used in service provider networks for point-to-point connections. 1.7 Describe the need for private IPv4 addressing. There are three ranges of addresses that can be used in a private network, e.g. your home LAN or office: 10.0.0.0, 10.255.255.255, 172.16.0.0, 172.31.255.255, 192.168.0.0, 192.168.255.255. Internet routers are configured to discard any packets coming from the private IP address ranges, so these addresses are not routable on the internet. 1.8 Configure and verify IPv6 addressing and prefix an Internet Protocol version 6 address. IPv6 address is a numerical label that is used to identify a network interface of a computer or a network node participating in an IPv6 computer network and for locating it in the network. IP addresses are transmitted in the fields of the packet header to indicate the source and the destination of each network packet. The IP address of the destination address is used to make decisions about routing IP packets to other networks. IPv6 is the successor to the first addressing infrastructure of the Internet, Internet Protocol version 4, IPv4. In contrast to IPv4, which defined an IP address as a 32-bit value. IPv6 addresses have a size of 128 bits. Therefore, IPv6 has a vastly enlarged address space compared to IPv4. How to configure IPv6? Cisco routers do not have IPv6 routing enabled by default. To configure IPv6 on a Cisco routers, you need to do two things. 1. Enable IPv6 routing on a Cisco router using the IPv6 on ICAST routing global configuration command. This command globally enables IPv6 and must be the first command executed on the router. 2. Configure the IPv6 global on ICAST address on an interface using the IPv6 address prefix length UE64 command. If you omit the UE64 parameter, you will need to configure the entire address manually. After you enter this command, the link local address will be automatically derived. 1.9 Compare IPv6 address types. A. Global on ICAST. The global on ICAST address is globally unique in the Internet. The example IPv6 address that is shown in prefixes in IPv6 is a global on ICAST address. The next figure shows the scope of the global on ICAST address as compared to the parts of the IPv6 address. B. Unique local. A unique local IPv6 address is constructed by appending a randomly generated 40-bit hexadecimal string to the FD008 prefix. The subnet field and interface ID are created in the same way as with global IPv6 addresses. The original IPv6 RFCs defined a private address class called site local. C. Link local IPv6 addresses. Link local IPv6 addresses allow communications between devices on a local link. Link local IPv6 addresses are not routable. They are used on a subnet. Normal link local IPv6 address prefix is FA80, 10. D. Anycast. An anycast address identifies multiple interfaces. An anycast transmission sends packets to only one of the interfaces associated with the address, not to all of the interfaces. This interface is typically the closest interface, as defined by the routing protocol. E. Multicast. A multicast address identifies 0 or more interfaces on the same or different hosts. A multicast transmission sends packets to all interfaces that are part of a multicast group. The group is represented by the IPv6 destination address of the packet. IPv6 multicast addresses start with French francs. Following are the important IPv6 multicast addresses. FF021, all nodes on the local network segment. FF022, all routers on the local network segment. F. Modified EUI64 extended unique identifier, EUI, as per RFC 2373, allows a host to assign IDSLF of unique 64-bit IP version 6 interface identifier, EUI64. This feature is a key benefit over IPv4 as it eliminates the need of manual configuration or DHCP, as in the world of IPv4. The IPv6 EUI64 format address is obtained through the 48-bit MAC address. The MAC address is first separated into two 24 bits, with one being OUI, organizationally unique identifier, and the other being NIC specific. The 16-bit zeros fee is then inserted between these two 24 bits for the 64-bit EUI address. IEEE has chosen FFF fee as a reserved value which can only appear in EUI64 generated from the EUI48 MAC address. 1.10 Verify IP parameters for client OS, Windows, Mac OS, Linux. It is very common problem in a big network. When a new device connected in a network, sometime duplicate IP address allotted to the client. The problem occurs because of networking devices. Each networking device have the feature of DHCP allotment to the clients. For example, when a new switch connected in a network without disable its DHCP service, it will start spread the default DHCP IP series to the network. The client when turn on it maybe capture the duplicate IP address from the new switch. To avoid duplicate IP address allotment by DHCP, disable the DHCP server of newly added networking device in the network like router or switch. Firstly, verify IP parameters for client OS, then disable the DHCP server in the new connected router or switch. Many time to use Wi-Fi in our laptop or smartphone, we connect the Wi-Fi router in the LAN without disable its DHCP service. This Wi-Fi router transmit the auto IP configuration in the LAN. It is possible that some devices get IP configured due to this router. so it is strongly recommended to disable DHCP services in all the network device before connect to the network. 1.11 Describe wireless principles. A. Non-overlapping Wi-Fi channels. Wireless communication usually involves of data exchange between two devices. A wireless LAN goes even further. Many devices can participate in sharing the medium for data exchanges. Wireless LANs must transmit a signal over radio frequencies, RF, to move data from one device to another. Transmitters and receivers can be fixed in consistent locations, or they can be mobile and free to move around. A Wi-Fi channel is the medium through which our wireless networks can send and receive data. The 2.4 GHz band has 11 channels, and the 5 GHz band has 45 channels. Selecting the proper Wi-Fi channel can significantly improve your Wi-Fi coverage and performance. In the 2.4 GHz band, 1, 6, and 11 are the only non-overlapping channels. Selecting one or more of these channels is an important part of setting up your network correctly. B. SSID. Service Set Identifier. SSID is a sequence of characters that uniquely names a wireless local area network, WLAN. An SSID is sometimes referred to as a network name. This name allows stations to connect to the desired network when multiple independent networks operate in the same physical area. C. RF is used in various electronics and appliances, which include radio and television broadcasting, cellular telephones, satellite communications, microwave ovens, radars, and industrial heaters and sealers. These are just a few applications. Electromagnetic waves are measured by wavelength and frequency. D. Encryption is the method by which information is converted into secret code that hides the information's true meaning. The science of encrypting and decrypting information is called cryptography. In computing, unencrypted data is also known as plain text, and encrypted data is called ciphertext. 1.12 Explain virtualization fundamentals. Virtual machines, simply put, it's the process of running a virtual computer. Virtualization involves software that allows you to run virtual systems, hardware, and applications from one single computer. It's most commonly used to run multiple operating systems, such as Windows and Linux, from one device. 1.13 Describe switching concepts. A. MAC learning and aging. MAC learning. The Layer 2 learning switch must be able to exchange frames between devices in the network automatically, identifying interfaces by their MAC addresses, learning where each one is located, and installing reactive flows and switches, handling the traffic based on the source destination MACs. MAC address aging. The dynamically learned MAC addresses are deleted after the MAC address age value has expired. This frees unused addresses from the MAC address table for other active subscribers. In Cisco ME 2600X, the default value for aging the MAC address is 300 seconds and cannot be changed. The expected MAC address expiration timer is between 300 and 600 seconds, depending on the number of MAC addresses learned. B. Frame switching. A switch is also responsible for forwarding frames intelligently port to port. As we know, the hub takes in frames and always forward that frames out to all other ports. But in switch, if its MAC address is fully populated for all ports, it filters the frame being forwarded out ports unnecessarily. It forwards the frames to the correct path based on destination MAC addresses. C. Frame flooding. If the destination address of any frame is not in the MAC table, the frame is forwarded to all the ports other than the port on which frame was received. It is known as unknown unicast flooding. It happens when the destination MAC address is a broadcast address. FFFF.FFFF.FFFF. D. MAC address table. In switch, the MAC address table is an important component. It contains the MAC address to port mappings that allows the switch to take decision while forwarding frames.